In this video, I will explain how to prepare a buffer solution of a specific pH using the Henderson-Hasselbalch equation. Consider the following practice problem. The pH of a bicarbonate carbonic acid buffer is 8.0. Calculate the ratio of bicarbonate to carbonic acid in the solution. Our first step in solving this particular problem is to write the equilibrium equation, where carbonic acid dissolves in water and reaches equilibrium with hydrogen ion and the bicarbonate anion. From a table of acid Ka values, the Ka value for carbonic acid is 4.2 times 10 to the minus 7. Taking the negative log of our Ka, we calculate a pKa of 6.38. At this point, we may use the Henderson-Hasselbalch equation to solve for my ratio of anion to acid. In the practice problem, we're given a pH of 8.0, and we calculated a pKa of 6.38, and we're asked to find the ratio of anion to acid. At this point, we would like to isolate our log anion over acid. Therefore, we subtract 6.38 from both sides of the equation. That gives me log anion over acid is equal to 8.0 minus 6.38. Subtracting these two values will now give me log anion over acid is equal to 1.62. At this point, we should clear the log on the left side by taking the antilog of both sides. That will give me concentration of anion over concentration of acid is equal to the antilog of 1.62. And our final answer becomes ratio of anion to acid, or ratio of bicarbonate ion to carbonic acid, should be 41.7 to 1. In other words, for every 1 mole of carbonic acid used to produce this buffer system, we should add 41.7 moles of our bicarbonate ion. Okay, let's try one more practice problem. The pH of a sodium acetate acetic acid buffer is 4.50. Calculate the ratio of anion to acid in this solution. So let's go directly to the Henderson-Hasselbalch equation. From a table of Ka values, I know that the Ka value for acetic acid is 1.8 times 10 to the minus 5. Going to our Henderson-Hasselbalch equation, the pH is given at 4.50. The negative log of 1.8 times 10 to the minus 5 is 4.74. And of course, we add that to the log of our anion concentration over our acid concentration. We may now calculate the ratio of anion to acid by first subtracting 4.74 from 4.50. Then we take the antilog of both sides of the equation. That will give us concentration of anion divided by concentration of acid is equal to 0.58. This will give us a ratio of anion to acid that is 0.58 to 1.